that has an imperative structure. It says that there is going to be a variable x. It is going to have the type int, and it will have the value 3. All of those things are declared, and that's the order that they appear in. And then if I say something like this, if I say x equals x plus 3, I know that this first line here, I know that line part 1 happens before line part 2. I'm guaranteed that with the imperative structure. This is not true for all programming languages. And so for a non-imperative programming language, the order that you write your instructions isn't necessarily the order that the instructions execute in. And so this is a little bit confusing. If you want to think about this as the next word, which is procedural, it's the same thing as if I write a function. If I declare a function, it doesn't necessarily mean that the function executes before the other parts. As an example, if I do the following, int, let's suppose this is C and I have a pound include pound stdio dot h. So this is in C. Int foo int x return x plus 1 int main printf %d3. Does the foo execute? Does the function foo execute? No, right? Even though it is declared earlier in the file, foo does not execute because our main is our entry part and our main does not call it. However, C is still imperative because once we start at main, we execute line by line, instruction by instruction until we get through. Even if we jump around a little bit, we're still executing in sequence. This is typically how we talk about programming. Things like database accesses, people talk about database administrators, and oftentimes people say that database administrators aren't really programmers, which isn't true in the slightest. They as much are as other people are, as we are, as regular programmers. The difference is that when you do database administration, you have to think about the problem differently. You can't think about the problem like this. Because the logic, it doesn't necessarily, because you start here doesn't mean you actually execute that first in some database administration tasks. You have to think about the problem in an entirely different way. Declarative. Declarative is very simple, similar to what imperative means, or not similar, I mean like almost the opposite. Sorry. Let me start that again. Declarative is almost the opposite of imperative. Declarative means you state what you want, not how to get it. You state what you want, and this is an example of a database query. When you think about, so we haven't looked at SQL, and you guys probably haven't talked about SQL. Let me do an example SQL query here, and we'll talk about the structure in it, and we'll talk about why it's still an example of a programming language, and we'll talk so on and so forth. So, as an example, I could say select star from people. There's 4 parts to this statement. We have the select statement. We have the from. Those are the what and the how. And then we have the people, which is the where. And this is the what again. This is the result. So we have the result, the where, the what, and the from where. That's when we're looking at that. Now the database that itself has this thing called a table, so we can think of people as being, if you want to think about this as an array list of things, array list of objects that are a bunch of people is an easy way to think about it in an array. But let's say people is an array of 10 billion people, right? And we want to be able to get all of the people from that database. This is going to get all of the people in that table or in that array. I can also I can have addendums to this. So for example, if I don't put the semicolon on there and I add stuff, I can say where name equals Scott. Now if I have 10 billion people, each one of those people should have a name part of their object, and this statement will give me all of the people where the name is Scott. So there might be 1,000 people where the name is Scott, but it doesn't matter that there's 10 billion people in the list. And so this statement right here says what I want, not how to get it. It doesn't concern itself with for loops, it doesn't concern itself with any loops. It doesn't concern itself with where things are in memory, it doesn't consider whether or not they're even on the same computer. Like if I need to store 10 billion people, or 10 billion websites, for example, if I was Google, could I store all 10 billion websites on a single computer? The answer is probably not. I'd probably have to store maybe the first 100,000 on one computer, the second 100,000 on another, and the third 100,000 on another. And then this select statement would be able to find all of the people regardless of what computer, what database, what memory address, all of those things. And I would get all of the ones that are named Scott. Now this statement might take 5 days to run, and I don't know how it works, but I don't have to tell it how it works. It just gives me the answer that I want. That's why databases are powerful, because they're declarative, not imperative. Questions about that? Anything about SQL in general? I mean, this doesn't obviously make a lot of sense yet. That's how they work. That's the basic idea. Structured. You remember what structured meant? That is called structured?
Yes.
Yeah.
Languages that contain all the common structures, if, else, loops, switches, etc.
So it's a language that has the common control structure, is what we talk about. So languages that have common control structures. And these are if, else, loops, loops. If you ever find yourself programming dumb, don't worry about it. I program dumb all the time. I just misspelled else again. I do it every day. Can someone come up with an example of a programming language that is imperative but not structured? We haven't used one in this class, but we have used one in general.
Assembly language?
Assembly language. So like the Motorola 68000 you learned in 237 is imperative but not structured. There is no for loop, there is no if statement, there is none of those things individually in the language, but it is still imperative. You write add, it performs 3 adds in a row. That's the idea behind the imperative. The structured means that it doesn't have an if statement. You can't say if do this, else do that. Now you do have labels and jumps and branches and things like that, but those labels are not the same thing because the branch is an instruction. If you want, that's how you want to think about it. If is not an instruction, if is a control. A little bit different. All right, what's the next one? Procedural. I said it earlier. Anybody got a guess? I want to repeat what I said earlier. Languages. Functions or sub-procedures built in. Some people want to say that assembly language is procedural because it has the ability to write procedures in them. I disagree. I don't know. I don't know if I have the right to disagree about that, but I don't believe that that's necessarily true because the difference is that, for example, Python has the ability to call a procedure without having to worry about how that procedure is kept on the stack, or if there is a stack. Whereas if you're in 237 and you're doing Motorola 68000, the procedures aren't given to you for free. You have to do all of the stack work yourself. And so the way you build a procedure in assembly languages is you have to build it yourself. It's not given to you. All of the languages we've used are procedural. That is correct. So Haskell is the only language we haven't talked about, and we're going to talk about it in a little bit next week. Is procedural, even though it is not imperative. It is not imperative, but it is procedural. And so you can have procedural things that are not imperative. We'll talk about how and why. We got the next one is, I believe it's functional. There's two kinds of functional. I'm just going to combine them into one. Functional languages. I've been yelled at before for saying the thing I want to say, but and people are right. But functional languages do not have variables as you are used to. So if you're used to thinking about things having what a variable is in programming, computer science so far, functional languages do not have them in that way. And so what we're going to say is we're going to say functional languages do not have mutable memory addresses. Let's not start with the do not. Let's start with composition of procedures. Composition of procedures. With no mutable variables. So mutable variables. As an example, and this is what we're going to do when we get to Haskell, this is not a valid statement in a functional language, x equals 3. That is not a valid statement. You can affect that in most functional languages, but it is no longer, x is not a variable. X is a label. If you remember in 68,000, or Motorola 68,000 from 237, if you set a label to a value, you cannot change that label's value. It's the same thing is true in functional languages. Once you assign a value to a variable, that variable is now fixed to that value in perpetuity for the rest of time. It is unchangeable. So if you say, for example, x equals 3 in Haskell, guess what x is for the rest of time? Or until you kill that program? 3. It is always 3. And this is the thing that makes it difficult, is because we go, well, how the fuck do you make that useful then? The answer is that you write functions as opposed to writing variables, and those functions are going to be composed of other functions. Because the parameters are not mutable, the parameters become fixed as they're assigned, but you can call the function multiple times. As an example, if we have a function f, so this is going to be legitimate Haskell. Let's call this function foo, which takes a single variable x. We want to return x plus 1. That's the way it looks. It's a little bit strange. Foo is the function x that returns x plus 1. I can call function foo by saying foo of 3 and foo of 4. And the first foo of 3 would return 4, and the foo of 4 would return 5 because it returns x plus 1. When we say foo of 3 here, this variable x is like a mathematical variable, which means that it becomes bound when called. And so when you're talking about x and y in math, and you talk about functions like f of x equals x squared, and you think about drawing the graph, and there's this parabola that goes like that, that's the kind of x that we're talking about. When we say, hey, what is the value at x equals 1? Y equals 1. 1, 1. What is the value at x equals 2? Y equals 4, right? When x equals 2, y equals 4, the function equals 4, every time. The value of 2, 4 is not negotiable. You can't say for some values of x, the value of y is 4. You can't say that x is 2 and 3, the value is 4. It doesn't allow you to change those. They become fixed forever. And this is always true. You can look at any value of x, it always has one value of y. Any value of y, well, some values of y have multiple values of x, but in general, that's the idea. And so the same thing is true here. When we say foo of 3 is fixed to the value of 4, whereas foo of 4 is fixed to the value of 5. And so we achieve these with a parameter passing here appears to be variables, but they're variables in the mathematical sense, not variables in the computer science programming sense. And so this is a very different way of thinking about problems. Does anyone have an idea why this would be important? Or why this is going to be powerful?
Would it be for parallel processing?
Yes. Why is that true?
Because threads can be performed independent of each other and independent of the clock.
Okay, but that doesn't answer the question why. Why is this parallel easily parallelizable, whereas other things are not?
Because if you happen to allocate memory for a variable and you try to use it in a separate function call, then it'll be an error.
Yes, that's true. Are you going to add something to it? No? So what you said is true, but it's a little bit roundabout. There's an easier way to look at it. If this is our function f of x equals x squared, everybody's okay with this plot, right? Nobody confused about that? If this is our plot, does it matter if I attempt to find the value of x equals 2 or x equals 4 first? Does the value of x equals 4 rely on the value of x equals 2? I could compute them simultaneously, and they're independent. And so what happens is, when we get no mutable variables, we get this thing called independency. Every function call is independent of all other function calls, which means that I can execute in parallel with every other function call. So as soon as I write something in a functional language like Haskell, if I write the function, I can then immediately parallelize that function to as many processors as I can have access to. And so if I have a server farm, for example, like Google does, where I have 10,000 computers in a room, each one of those computers has 2 processors with 32 cores on it. Each one of those cores can have 2 threads on it. So I get 64, I get 128 threads per computer, and I have 10,000 of them. I get a million some CPU processes that I can do. If I write it in Haskell, I can in each of those process threads execute one iteration of the function simultaneously to do millions of operations simultaneously at the same time. This is the concept of Hadoop. So whenever you talk about big data and you talk about Hadoop, how does Hadoop and big data work? Hadoop and big data are functional languages that operate across thousands of computers simultaneously in parallel because the functions are independent of each other. Without that independency, you don't get that Hadoop, and you can't do that Hadoop. You can't say, I cannot process thread 7 with argument x. I can process, computer number 14 will process these 32 values all simultaneously. You can't do that unless you consider independent. So functional languages lead to this concept of independency, which is really important for these big data processes.
Is there any game programming that occurs in Haskell for physics engine?
People try, yeah. There isn't any mainstream AAA games that are. People definitely do. The problem though is you might be able to do some of the physics engine in it, but in general the problem is it's not easy to program in Haskell. For example, the language itself is not friendly. The language is geared towards mathematics. Let me write independency up first, and we'll talk more about it. There's many functional languages. Typically, though, functional languages, because they're driven by mathematics as opposed to driven by still trying to solve computer science problems, they're very, very terse. And they appear to be mathematical equations as opposed to being programming, like programs. As an example, let me write in the Ackermann function. Let me see if I can write the Ackermann function in Haskell. Then we'll try to write. Let me write it on the next board. And I'll try to write it in Python. And we can see the difference. I'm not that good at Haskell. That's the problem. Oh. It's something like that. That's generally the statements in Haskell. I don't know how to do these combinations quite right. Maybe I'm thinking K. But can you figure out what the Ackermann function is from trying to read that sentence? So besides the fact that I'm probably wrong, but if I wrote this correctly and you even knew the language, you'd have to sit there and parse it for a little while. However, if we did the Ackermann function in Python, I could do this. It might be n minus 1 over else return Ackermann something like that. I might have the Ackermann function wrong, but in general, when we're looking at this now in Python, I can see that there's an if-else chain going on here with recursive calls to Ackermann. Now it's difficult to suss out from this and what's going on inside of the way Haskell reads its language. The difference is that I can try to compute these simultaneously, which means that I can compute multiple Ackermann calls at the same time, which means I can actually find the answer. For example, the Ackermann function is the largest growing function. You can find Ackermann of 3.3 as an example in about a quarter of a second, but Ackermann 3.4 takes about 2 seconds, and Ackermann 3.5 will take about 20 seconds in computation time. Ackermann of 4.1 is not computable on most computers, and Ackermann of 4.4 is not computable in our lifetimes if you do it the standard way, just because of the way that the growth factor. And so this is an example of trying to do something functionally versus procedurally. And it's difficult to read. It might be difficult to read both of them, but it's easier to read the procedural. I don't know if that's helpful or not. I'll scrap it. We'll talk about functional languages more when we talk about Haskell next week. Okay. So functional languages give us this concept of independency, which is what we're looking for, even if we don't quite understand them yet. That independency is what gives us the power to do things like big data and Hadoop, simultaneous data computations. What are we missing? Big fat one we should be talking about. We don't even need to talk about it, we just need to list it. Object-oriented. Thinking in terms of things instead of actions. All right. I'm not going to talk anymore about object-oriented. We've talked about object-oriented to death. We have one more I'm going to talk about before we talk about multiple Python files, which is logical. Anyone want to have a stab at what logical means?
Relationship language.
Don't read it off the window.
I'm reading it from my notes I took on my lecture.
Oh, okay, fine then. What did we say?
Relationship language which determines relationships between data, mostly on expert machines like oil-based.
So logical languages have a set of rules. So we'll expand that. So we'll say sets of rules on data. And so when we have a set of rules and we have a set of facts, we can apply those set of rules to those set of facts to derive new facts. So we can apply rules to facts to derive new facts. Expert systems is the most common use of these. We see expert systems all the time. Expert systems are usually your if-else chains or your switch statements. That's an example of an expert system. But usually a full-fledged expert system is a little bit more powerful. Logical systems have two subparts. They have, or one subpart which does two different directions. We have something called the inductive logic, or the inductive logic. I just had it in my head. Accompany. So induction. So the way we do this is we use induction. This is the reason why my brain's not able to think about it off the top of my head. I think it's called the induction engine, right? Induction. It's the wrong word. I'm trying to remember what it is. It's something engine. Hold on. But the sorry. We'll figure out what the real word here is in a minute here. But there's two parts that this engine does. It can either do forward chaining or backward chaining. Forward chaining is when you take a set of existing conditions or existing facts and you determine what can occur.
Inference engine?
That's the word, thank you. I don't know why my brain totally... Inferencing. My brain totally second-faulted on reduction. Take a set of known information or known facts and determine what's possible. This kind of concept is also the idea of determining relationships that you haven't determined yet, or you haven't specified. A very common example of this is when you use a language like Prolog. We, as humans, do this constantly. Let me erase a little bit here, and then I'll do one on the We do this constantly with forward chaining, and we do it with backward chaining as well. If we have, let's say we have 3 people. We have Bob, we have Sally, and we have Gene. So let's suppose those are the 3 people that we have. And we have a rule where a person's mother's mother is that person's grandmother. Is that true? A person's mother is that person's grandmother, right? And so if we say Sally is Bob's mother, and we say Jean is Sally's mother, we as humans automatically know, what about Jean? Jean is Bob's grandmother. We know that. Prolog is a language that allows you to do these relationships. So you'll put Bob, Sally, and Jean in the knowledge base, or in the set of facts. You put this as a rule. You put these as facts, and then the knowledge. You say, what else do you know? And the system will say, hey, well, Jean is Bob's grandmother. Even though I didn't explicitly tell the system that Jean is Bob's grandmother, the system will determine that for itself. This is a system of forward chaining inferences. This allows us to deduce information that isn't explicit. You can do very, very complicated versions of this. Have you guys heard the riddle about, what is it? This man's father is my father's son. Who am I? This man's father is my father's son. Who am I? It's me. Well, so it could also be my brother, would be an example of that. And so if we would be able to, if we put all those rules in there and we put that as a fact, the logic engine would be able to say, it's you, or your brother, or any of those other systems, or those other possibilities. That's an example of forward chaining. Backward chaining. Anyone want to take a stab at what backward chaining is? So yes, one of those things. So we can do that. That's not considered backward chaining. That would also be considered forward chaining, but that would be considered forward chaining for rules. And that's inductive logic, where we have inductive rules, and we use this as humans all the time. The problem is that inductive logic isn't necessarily true. It's kind of like I press the light switch, the lights turn off. When I press the light switch, the lights turn on. Therefore, the light switch control is the thing that makes the lights work. And that's not true. The electricity is what makes the lights work, and the switch controls the electricity. And so we can fall into that inductive logical fallacy, which would have the same problem with the inductive engines that are forward chaining on rules. So you have to be careful about that. But you're right, we can do that, but that's still forward chaining. Anybody else? So that's the same thing that he just said. It's still forward chaining. So backward chaining is you take a set of facts. It starts off the same way. You take a set of known facts, and you don't determine what is possible. What you do is you determine how to reach a new state or a goal state from your existing state. So let's word it a little bit differently. Determine how to reach a goal state from a set of known facts. As an example, let's suppose that we only have Sally as Bob's mother. That's the only rule we have, right? And if we want, the goal that we want is we want Jean is Bob's grandmother. Right? That's what we want. We have no information regarding Jean and Sally right now. But based upon the facts that we do have, if there are only 3 people, and we know that Sally is Bob's mother, and we want Jean to be Bob's grandmother, what must be true? Jean must be Sally's mother, right? This is an example of backward chaining. Now, is this always true? This is not always true. When would this not be true? So we want Jean to be Bob's grandmother. When is it not true that Jean is Sally's mother? Say that again? Jean is Sally's what? So Jean could be Sally's mother-in-law, or we could have a different one. What if we introduced Ken? So now we have another person in the mix, and we say, hey, there is Ken. We can also have Ken is Bob's father, and Jean is Ken's mother, right? And so this would make it so if we had Ken as Bob's father and Jean as Ken's mother, that would also make Jean Bob's grandmother, without having to do any steps or buried ins or any of those other nonsense. But how many possibilities are there to make Jean Bob's grandmother? There's only 2 of them, right? You're only going to get either the father's mother or the mother's mother. One of the 2. Those are the only 2 options you can get. And the backward chaining, when properly implemented, will give you both of those. You go, here are all the possible solutions to this problem. Pick one. So based upon insufficient information, we can deduce all possible outcomes or all possible organizations of that information and then say these are the possible versions of that. When would this be useful? So when you're doing things in mathematics and you want to say, hey, what are all the possible answers to this equation? This is one version of that. It allows you to find all the possible equations to that in mathematics. And it is used that way. There are languages. Are you guys familiar with like Mathematica? That's the point of that language. R, MATLAB, those all do these things. They all have these built into them. Mathematica, I think it's Mathematica, is specifically designed to do this though. It's the whole point of Mathematica is to be an inference engine in a logical system with backward chaining, so you can do that. And it's expensive, so if you figure out an easier way to do it, feel free to make a lot of money. What's another system that backward chaining would be very good for? Huh? So what is a real life example of a maze? Okay. And what would want to use maps? What about an automatic car? Right? I want to get to this location. How do I get there? That's an example of a backward chaining system. And as new information is given, like, hey, there's cops this route or there's an accident this route, you need to make decisions on how to navigate those. And if you have all possible options on how to get somewhere, you can then rank them in terms of plausibility or goodness. And then that'll give you an automatic system that'll be able to automatically take you someplace. That's a real-world situation where we use backward chaining in real life. Other kinds of goal-based systems. Whenever you play a video game where they say, hey, this agent has goals, as soon as they say that, that means they have some sort of inference engine with a logical system based with backward and forward chaining. In any video game, it says that. Anytime people talk about typically, anytime people talk about AIs that have goals, there's this kind of system at work. AlphaGo works upon a loose combination of these two. They talk about it has multiple neural networks, and they both go up and both down. That's the two things that they're talking about. All of the systems do these kind of things. This is the first. This is the first introduction to artificial intelligence that's true AI, is logical inference engines. We've had them forever. We're just not very good at it.
There's a microchip that they developed that's supposed to be really good at perhaps performing these kind of collaboration. It's supposed to create associations.
So that the chip that you're talking about uses neural networks, I believe, artificial neural networks, which is a different method of approximating the same thing. The difference between what you just said is statistical machine learning, and that's an entirely different branch of artificial intelligence. This kind of deal here, we have to be able to know all of the rules. What you do with statistical machine learning, you say, fuck it, I don't know any of the rules. You throw everything in your hands, and you let it determine the rules on its own. Whether or not those rules are any good, you have no idea. You don't actually know the rules that it learns. You just kind of go, eh. Sometimes it works, and sometimes it doesn't. You get lucky, you get lucky. And the goal is to get lucky all the time. That's most people's goal. All right. Any other questions about this kind of stuff here? There's some more if you look online, but we're not going to talk about them because they're not as important. Okay, so let's talk about Python so we can do the homework assignment that's going to come out. Let me do it on the overhead. Right. Fortunately, Rohan has Python for us. We don't have to worry about writing a Rohan or a Python interpreter for us. I'm not going to use the REPL, which we used on Thursday, simply because REPL doesn't do what we want it really to do. So, what I want to show you. Assignment has not been posted. All right. So if I type in Python at the command line terminal here, we get what version of Python are we using? Python 3, right? So if you're starting writing code, your Python doesn't work the same as it does on your Mac. That's because Mac by default comes with Python 2. Or if you've installed Python 2, is not exactly the same as Python 3. So just be aware that some of the things aren't going to be different. If on Rohan you want to quit out of this, you use Control D. Control D is the end of file character. When you pass the end of file character, Python will exit. You can also kill it by using the Control C. So if you're doing something and you want to exit out of it, so for example, I in range of 1 to, let's never end. Print I, right? So if for some reason you're like, ah, shit, Control D doesn't end it yet, this will never finish, unfortunately. So you use Control C, and that'll kill it. It still takes you back to the Python level there. If you hit Control C again, it just gives you quick keyboard input. So you really want to exit, use Control D. Cool? Let's suppose that I have a file here. Let's make a pico. Foo.py. What I'm going to do here is I'm going to write a function called foo. I'm going to say def foo. Let's make this, take the variable x and we'll return x plus 1. Now if I run Python, how do I get that function foo? So I can say, for example, foo of 3 is the question. Does anyone have a guess? So if I say, for example, here, if I say Python, what do I call it? Foo.py, right? If I do that, what occurred? You're right, though, but what occurred here? It ran it. What did it run?
But it didn't run the function, just tweeted something that came in.
Right, because I didn't call the function at all. So let me actually call the function inside that file real quick. So if I add down here, if I say foo of 3 down there, and I write that and then I run it again like I just did, right? I ran the function now, then did I not see anything? Why don't I see anything? I didn't print it. So let me go back in there and say print foo of 3. I should probably spell print right. No, correct. There we go. Foo of 3 is 4. Excellent. But what if I want to be able to say Python and then use foo multiple times? Here. How do I get access to it?
Import it somehow.
So inside of C, do you get printf for free? No. What do you have to import or include to get that? stdio. So in Python, you get most of the things you want for free, but anything that you don't get, you need to bring in, like an include or an import. We're going to use import. So if I say, for example, import, I can import. I can import files. So for example, if I want to import foo, I'm going to say import foo. I do not put the .py on the end. I just say import foo, like so. Now I've imported foo. What happened when I imported foo? It ran it, so I got that print 4 in there. But now I have that foo, and so now I can say foo of 4, like so, which goes, hey, stack error, shit, or not stack error. Module object is not callable. So in Python, callable things are functions, and it says that foo is not callable, is essentially what it means. But it's saying something else. What have I learned from this? And why am I now? Yeah.
How do you determine some
Hashtags. Pounds. I'm sorry, I don't know what those characters are anymore. Pound sign, hashtag. Yeah. I believe that's right. Yeah. What have I learned? What is the error here? I do want to do that, but before I get there, what have I learned here? Correct. Everything that I imported, when I said import foo, I imported into its own scope. And the scope that I imported it into is what we call a module. And so when I look at that, how do I know that foo is a module, or it's the scope, not the function foo that I'm talking about? Where does it say that? It says error in Stein line 1 in module. So in module there's an error, which is the current thing that's running. Module object is not callable. So when I say foo, foo is the module. So if I print, it's all caps there. Foo is the module from foo.py, which means it's the scope. It's the entire scope that's inside of foo.py. Now, if I want to get the function foo, which is in foo.py, I have to access it through the module foo. So I have to say, for example, let's say print foo.foo of 4, which is 5. Because the function foo is inside of the module foo, or is the scope foo, that I can now call. I'm going to go ahead and kill this Python. I'm going to restart a new one. I'm going to import foo as var. Now if I try to print foo, foo is not defined. Why is foo not defined? Because it's called bar now. When I said as, I redefined that module to be, instead of being called foo, to be called bar. And so everything that's inside of that foo file is now inside of the bar module. How do I actually call that? How do I actually call the function foo now?
Bar.
Bar dot
Foo.
foo. Like so. Which is 6. This is one way of importing things. Let me kill Python. Do another one. I can also do, for example, from foo import star. When I did this, I now did something else. What I've done is I've imported things from the foo module into my local scope. And so now if I say print foo, let's see this. You'll notice that foo is the function, not the module. Depending upon how you want to use the functions or the classes or the things that you define, depends on how you want to import them into your local scope.
So you define the scope and module interchangeably?
Yeah, so the module contains its own scope. Yes.
So you're loading it into your current module.
It's kind of like a namespace in C++ or C, or a namespace in Java or C#.
And then you can call your file
Correct. I can say foo of 10, for example, because foo is the function, not the module, because I said from that module foo import everything. You can also do specific imports. So for example, if I say from, let me go, actually hold on, let me make this, oh, God. Be careful when you're hitting Control D. What am I doing? Oh yeah, pico foo.py. Def foo2 of x returns x times 2. Like so. So we have the two foo functions. We have foo and foo2. There's the two separate functions. I can import them individually. So for example, when I run Python, I can say from the foo, which is the foo file, I can say import, instead of star, I can say import foo2. Oh, for foo. From foo, import foo2. So from the file foo, import the function foo2, which now means that I can call foo2. Foo2 of 3 is, oops, no, hold on. 3 is 6. Foo2 of 3 is 6, but I cannot call the function foo when I did not import. Yes?
What if you import content to the file first, and then you import the file after that, and you call the first foo, which has the same name?
So Python will replace. And so the last thing that's imported will be replacing whatever was previously imported. Good question. So for example, if I say from foo import foo, right? Which means that I have that function foo. So I can say foo of 3, which will give me 4. And then I can say import foo, right? Now if I say foo of 3, it'll say the module, because the previous foo was overwritten by the new import. That is correct. So you need to be careful that you don't overwrite your own names and things like that. You can also do redefinitions during the import. So for example, if I say from the file foo, I want to import foo2 as some other name, like so. Now I can say some other name of 3. That's how I avoid importing multiple things with overloading the names. Cool? All right, so how do we use this? Let's remove foo.py. Let's make a class about something. What should I make a class about? Yeah, anything? Monkeys? All right. So we'll have Python, oh not Python, sorry. We're gonna have pico monkeys.py. This is gonna be class monkeys, like so. We'll do the bananas like we did before, equals 3. We'll def underscore underscore 2 underscores in it, underscore underscore, self, comma, let's not put anything inside of it yet. Let's give it a name. Self.name equals name. And we'll define the function throw, which will take self, and we can print self or throw item. Self.name concatenate with throws item. So we have this class monkeys that'll have the static variable bananas that has the init, which is the constructor, and has the function of throw. What is the member variable that we defined? Name. And so each object is going to have a name parameter, and we're going to use that name parameter in our throw when we use it. Let's go and exit. Now when I run Python here, if I want to import monkeys, I can import monkeys. Oops. Because the files with the lowercase n, so I get monkeys. Now if I want to make an object of type monkeys, how do I do that? Do you know the answer already? Hold on. I want you guys to think about this for a second. How do I make a new object of type monkeys? What do I say? So for example, I want a equals. So in the file, I have this thing called monkeys with a capital M. Do I get to say monkeys with a capital M here? I do not. Why do I not get to say monkeys with a capital M yet?
Because you imported it at lowercase.
Because when I did my import, well not that import, when I did my import here, I imported monkeys, which means that I get a new scope inside of that module monkeys there. And the monkeys class is inside of the monkeys with the lowercase m scope. And so if I want to be able to make monkeys, I have to say monkeys.monkeys. Right? Now I'm going to give myself a name, which is, let's call this one Joe, like so. And if I say a.throw, is capital T, I don't remember. Yeah, it is. Throw stuff. Joe throws stuff. Right? Any questions about that? All right, let me do a new one. I'm going to say import monkeys as m. How do I create a?
M.monkeys.
I have to name the scope that the monkeys class is within, which is named m now instead of monkeys, because that's what I did with the as. So I can say m dot in the name of the class, which is the capital name monkeys. That's monkeys. And we'll name this monkey Jim. And then I can say a.throw. What do you think will happen when I type in the 3 there? A.throw 3. What do we expect to occur, and what might actually occur? What do we expect to occur?
There.
Well, stop. What do we expect to occur? Jim throws 3. That's what we want to occur, right? However, when we run this, we get a type error. Cannot convert int object to string implicitly. Python does not do automatic coercion, So languages like Java will automatically coerce integers and floats into strings. Python doesn't do that for you. If you want to be able to turn an integer into a string, you have to explicitly do that. So what we're going to do is we're going to open up monkeys here, and what I'm going to do is I'm going to turn that item into a string. I believe you just say str around the item, like so. I believe that's correct. We can check that real quick here with Python. So Python, I'm going to say print string of 3. Excellent. So str of 3. So I can actually add this. So for example, the difference would be 3 plus hello, unsupported, but if I print the string str of 3 plus hello, I get 3 hello. That'll do the recursion for us. I'm going to kill it, reopen it. I'm going to from monkeys import monkeys. How do I create my object now? A equals monkeys with a capital M. Do I need to have any prefix to it? I do not. Why not? Because when I do the from, I import it into the current scope. When I say import first, I'm importing a new scope into my scope that I have to access through the scope, the module. Let's call this Sally. Let's say a.throw 3 for Sally, and Sally throws 3. Any questions about this? Yes?
How does the str go into it? Does it just ask, like if I gave it an object that's like not a primitive?
Uh-huh. So let's say a.throw a, right? Because when we say a.throw a is the object monkey, and a is also an object monkey, and so we're trying to throw that monkey, right? Let's see what happens when we do that. Sally throws monkeys.monkeys object at that memory address.
So is there like a two-string type function that you can override?
How would you find out?
Look it up.
Okay, so let's Google it. Python two-string method. How do I change the string representation of a Python class? The closest equivalent to Java's two-string is to implement the str. You see it's underscore underscore str. For your class, put this in your class definition. Return something like that, right? So let's use that. Def underscore underscore str underscore underscore with the self. We'll go ahead and return monkey plus self.name. Is that okay? Now we'll go ahead and do the Python import or from monkeys import monkey as banana. Monkeys. From monkeys import monkeys as banana. How do I create a new monkeys object? Right? So because I did the from, that means I'm importing into my local scope, so I don't have to use the scope identifier, the like monkeys or anything. But I'm importing the monkeys class as the word banana. So if I want to create that monkeys object, I'm going to create a banana. So I'm going to say a equals banana of Fred. And now if I print, if I say a dot throw a, Fred throws monkey Fred. Answer your questions? Other questions? Somebody else had their hand up. No? Okay. I either answered it, they don't care anymore. One of the two. Maybe a little bit of both. let's do the last thing we're going to do is we're going to write another Python function script here. So Pico, let's call this fizz.py, I don't know, we'll call this foo.py. Foo.py. If I want to be able to use the monkeys in this file, how do I get it in here? Let's use it. So we'll say import monkeys, like so. Now I want to create a monkeys object, so we'll say a equals monkeys dot monkeys. Sally again. George. Yeah, George is monkey. And then I can say something like a dot throw a. Now if I want to run this file, I can say Python. I did. Monkeys. Oops. Thank you. So now when I do Python foo.python, you'll see George throws the monkey George. There is another thing that we want to be able to do. What would be the other thing I want to be able to do inside of foo? Instead of just starting from the top, what kind of things should I want to be able to do that we might have, that we have in other languages that we haven't seen in Python yet? Have a main function, right? So how are we going to find out how to use the main function?
Google.
We're going to Google it. So we're going to come in here, we're going to go something along these lines. We're going to say Python main function. And there's just going to be lots of, understand the main method in Python Stack Overflow is usually where I would go. And you try to figure out how all these different parts work together. There's all, I don't know, it goes on for, it's a pretty long answer for Stack Overflow. Might be a little bit more complicated than initially seems. So go ahead and make sure you can understand and figure out how to do that on your own. I'm not going to show you how to do that, so there needs to be something for you guys to do on your own. We can be done for today. If you have questions or you want to get your test back and you didn't get your test back, please follow me to office hours.